Hi everybody, so in this lecture we will solve page 35 exercise XLV. So given we have a triangle, an isosceles triangle ABC, so we have the two sides AB equals to AC and the two angles ABC is equal to angle ACB, and it says that the bisector of angle BAC cuts BC at M. So we have the two angles BAM and MAC are equal. So in part 1 it says first that let n be any point of side AM, so we just place n any point of the side AM, and the first question A, required to prove the two triangles ANB and ANC are congruent. So the first information we have is that the two sides AB equals to AC given. Also we have the two angles BAM and MAC are given equal, and we have the side AN is the common side between the two angles. So we can conclude that the two triangles are congruent by side angle side. The homologous elements are first we have the two sides NB is equals to NC, and the two angles BNA is equals to CNA, and NCA is equals to NBA. Question B, required to prove the triangle NBC isosceles. So by part 1 we have the homologous elements that the two sides NB is equals to NC. So we can conclude that the triangle NBC is an isosceles. Moving now to part 2. First given we have that E belongs to the semi-straight line MA, and A should be between the 2 points M and A. So the only way to plug E is that A should be between the 2 points M and A. So we just place E above A. And the first question is required to prove the two triangles EAB and EAC are congruent. But before proving these two triangles congruent, let me remark the new rule. So we will learn a new rule. It says that in any isosceles triangle, the heights inside this triangle, this isosceles triangle, heights, bisectors, medians we will talk about later, and the perpendicular bisectors are overlapping. Overlapping means that they are the same. So inside any triangle, any isosceles triangle, especially isosceles triangle, the height is also the perpendicular bisector is also the bisector, and vice versa. So to prove these two triangles congruent, first we have two easy information: AB is equals to AC given, and also EA is a common side. But the last information is that EA is equals to EB. Why we can say that EA is equals to EB? Well, since AM is a bisector inside the isosceles triangle ABC given, so we have this information. So ABC is isosceles and AM is a bisector inside it. So this AM should be also a perpendicular bisector inside this isosceles triangle. So AM is the perpendicular bisector of BC. Then also we have that point E is on the straight line AM, and AM is the perpendicular bisector of BC. So E should be, this is another rule we learned, any point on the perpendicular bisector is equidistant. So E is on the perpendicular bisector of BC, then EB should be equals to EC, and then we can conclude that these two triangles are congruent by side. Last thing, please do a homework, page 34, exercise XLIV.